All right, welcome. We're going to do a problem here from section 4.5 regarding L'Hopital's rule and indeterminate forms. Let's go ahead and take a look at, I'm going to go ahead and give a problem on the iPad again. So there's one each of 0 over 0 problem and infinity over infinity. So one of the things I'll ask you to do in solving these problems is demonstrate that, first of all, it does qualify for using L'Hopital's rule, which means it does present when you take the limit to the value that's given in the function, that it does produce an indeterminate form, and that is the restriction for using the L'Hopital's rule. So I would recommend that you start the problem with the limit as x. Verify that if I plug in 2 squared plus 2 minus 6 over 2 squared minus 6 plus 2, I get 4 plus 2 is 6 minus 6 over 4, I get minus 2 plus 2, which is 0 over 0. So it does check, it does qualify. So now you go back to the original function, limit as x goes to 2 of the function, of the rational function, and notice that that is equal to the limit by L'Hopital's rule. It's saying that is equal to the limit as x goes to 2 of the derivative of the top over the derivative of the bottom, which is 2x plus 1 over 2x minus 3. And now it's a matter of plugging the numbers in here. And in this situation, you end up with, what is that? That's equal to, plug in 2, you get 4 plus 1 over 4 minus 3, which is 5 over 1, which is 5. Therefore, the initial question is the limit. What is the limit as x goes to 2 of x squared plus x minus 6 over x squared minus 3x plus 2 is equal to 5. And that is using L'Hopital's rule for the 0 over 0 indeterminate form. Now look at the second one here. The limit as x goes to infinity of 1 on top, this gives us infinity squared, which isn't a number. X is going to infinity, it's getting huge, so we don't plug in infinity actually, so we can recognize the thing is getting huge. So the way we do make the notation is we've got infinity going on up on top, and we've also got e to the infinity, so we end up with infinity on the bottom. E to the infinity is a huge number, so we've got infinity over infinity. Therefore, the limit as x goes to infinity of x squared over e to the x is equal to the limit. Remember, this is an important part of it. Write out that limit symbol as x goes to infinity of the derivative of the top over the derivative of the bottom. Notice again, what do we get? We get infinity over infinity. So as a result, we end up saying we can use L'Hopital's rule again. So we can do it a second time. So we end up with this is equal to the limit as x goes to infinity of 2, the derivative of the top over the derivative of the bottom, again, the derivative of the x is e to the x. So as x goes to infinity, the denominator is getting huge, so we've got a constant over something that's going to getting huge, and that turns out to be going to, it's huge in the bottom and it's limited on top, therefore it's going to 0. It's going to 0. So it's getting 2, it's going to 2 over infinity would be the notation, I guess. And again, you don't necessarily write infinity as a value, but as it's getting huge on the bottom, this is going to, it's going to 0. So the limit, so going back to the original question, the limit as x goes to infinity of x squared over e to the x is equal to 0. Another problem, and we'll hit another one in just a little bit. Got questions? Make sure you get in touch, go over, look over it again, and verify that you understand the concepts there. You first had to determine that it was an indeterminate form, whether it was 0 over 0 or infinity over infinity. And if it comes back and it's infinity over infinity a second time, then you just got to do it twice. And it ends up being the answer is 0. So thank you, and let's move on to other